Alright, solving equations with variables on both sides of the equation now. So our steps for solving equations when we have variables on both sides. Our first step is that we need to simplify. If it's necessary, or if needed, on both sides of the equation. So what things we look for when we simplify? Well, we might need to use the distributive property, which is the when there's parentheses, and there might be like terms that we need to combine. So we use then inverse operations of addition or subtraction to move all remaining variable terms to one side. So again, we're going to first simplify, which means distributive property or combine any like terms. So we should just have at most a variable term and a constant on each side. And then the idea is, since we do have variables on both sides, next we're going to move all those variables to just one side of the equation. And again, we do that by using an inverse operation. So in order to move something or to undo it from one side and apply it to the other side, we use that inverse operation. So in this case, if it's positive, we're going to subtract it to move it to the other side. If it's negative, we'll add it to move it to the other side. And what we'll find out and see in the examples is it doesn't matter which side we move the variables to. We may try to keep it so that the variable term will be positive. Okay, so it does not matter which side the variables move to, but if we can keep the variable term positive, it just makes it a little easier to work with a positive coefficient instead of a negative one. What we should be left with then is a two-step equation. So this is why I had you practice these yesterday, because then we should be left with a two-step equation to solve after that. So remember that we undo or move the constants then that's on the same side of the variable first, and then remove or undo the coefficient. Okay, so looking at our examples here, just solving the equations. So I have negative 11 plus 5n on one side is equal to 1 plus 3n on the other side. I don't have anything to simplify in this one, so I have no distributive property or no like terms to combine on each side. Each side just has a constant and a variable term, a constant and a variable term. And so we're going to move right into step 2 then up here, which is use an inverse operation of either addition or subtraction to move all of the remaining variables to one side of the equation. So my options here to move all the variables to one side of the equation, I could either subtract the 5n from both sides, and if I subtracted 5n from both sides, it would get rid of it on this side. Over here, subtracting 5n from 3n is going to leave me with negative 2n. Or I could subtract the 3n from both sides and remove it from the right side. Subtracting 3n from this 5n over here is going to leave me with positive 2n then when I do that. So that's the route that I want to go, just so that I have a positive coefficient that I'm left with. So I'm going to show here that I'm going to subtract 3n from this side. Also subtract 3n from this side. And notice that I wrote it right underneath the 5n. Because remember, I can only subtract an n term from another n term. It has to be a like term that I subtract it from. So I can't subtract the 3n from the negative 11 here, because those wouldn't be like terms. But in this case, I'm going to get rid of it there. The negative 11 stays the same, but now 5n minus 3n is going to leave me with 2n. And then I still have that positive 1 on the other side. So after moving the variable terms to one side, now I have that two-step equation look where I've got a constant and a variable term on one side, and then just a constant on the other. So now I undo my constant that's on the same side as the variable, which is the negative 11. In this case, we would add 11 to both sides then to cancel it out here. Get 12 over here. Divide by 2 then on both sides. And n is going to be equal to 6. Okay, number 2. So I've got 10 plus 2p equals 8p minus p. So simplifying first, on this side just a constant and a variable term, so nothing I can do with that. But over here I have two variable terms, and they're the same variable, so they're like terms, so I can combine those. So I can do 8p and negative 1p. In this case, they're on the same side, so I'm just combining like terms, which means I just follow the operations that are shown. So a positive and a negative means I subtract. So 8 minus 1 will leave me with 7p over here. Now that I have it simplified, I'm going to move all the variable terms to one side. In this case, since there's only variable terms on the right side, I want to take the variable term that's on the left side and move it over there with it. It's just going to create less steps as I go further into this problem. You could technically move it over here to the left side, but then you'd have to move your constant back over and then divide. But this way, when I move it over, I'm actually only going to be left with a one-step equation. So if I subtract 2p from both sides here, it's going to cancel out the 2p here, leave me with 10 is equal to 7p minus 2b, which is 5p. Now I only have a one-step equation because the only thing to get rid of that's with the p now is the 5, so just divide by 5 on both sides, and we get 2 is equal to p. Okay, number 3, similar to number 2, where I have like terms that I can combine over here on the right side. So I'm going to take care of that first. This time it's a negative and a negative, so negative 5n and negative 1n is going to make negative 6n, because remember, same sign, keep and add. Again, only variable terms on the right side, so I'm going to move this negative 8n over to this side. Inverse operation then would be to add 8n to both sides here to cancel out the negative 8n on that side. So I get 16 is equal to negative 6 plus 8. Well, that's opposite signs. Subtract, keep the sign of the larger, which would leave me with positive 2n. Divide by 2 on both sides, and I get that n is equal to 8 for this one. Okay, and number 4, negative 13 minus v is equal to 4v minus 3. Nothing to simplify on this one, right? So just a constant, a variable term, and a constant on each side. So this is similar back to like number 1 that we had. So I have the options of either moving the v terms over to the right side. If I did that, I'd be adding v to both sides, and that would give me a positive 5v over here. Or I could subtract this 4v from both sides, and over here subtracting it from negative 1v would give me negative 5v. So I'm in favor again of trying to leave that positive coefficient, so add v to both sides would be my preferred method. Leaves the negative 13 on that side. Over here, I get 5v minus 3. Add 3 then back to both sides to remove the constant from the variable side. I get negative 10 is equal to 5v. Divide by the 5, and negative 2 will equal v. Okay, in the column, it's summarizing the steps for solving a multi-step equation, so you're basically just summarizing what it says for numbers 1, 2, and 3. Good practice for you to do on your own there. When I post my answer key or my filled-in copy of the notes here, you will see what I write for that, but feel free to take a moment to do that there on your own. But moving on to the next examples, number 5, this time you're going to notice that we've got some parentheses. So remember, parentheses usually in solving an equation tell us that we need to do some distributive property. In this case, there's just a negative in front of the parentheses, so remember that means that there's really a negative 1 there. It's one of those times where we have one of those invisible 1s. So that negative 1 is what I'm going to distribute in, which again means multiplying. So negative 1 times 1 is negative 1. Negative 1 times negative 2x is going to give me a positive 2x. I still have this other positive 2x that I'm going to put there, plus 2x. And then on the other side, nothing has changed, still just 29 minus 6x. I still have more simplifying I need to do on the left side though, because now I have like terms. So these 2x terms are going to combine, and that's going to give me 4x on that side. Okay, so now after I've simplified, I've got negative 1 plus 4x is equal to 29 minus 6x. I have variables on both sides. I want to fix that next. So I either subtract 4x from both sides, which would give me a negative 10x over here when I did that, or add the 6x back to this side, and that'll give me a positive 10x. So again, I'm in favor of leaving that positive coefficient if we can. Now, two-step equation. So move the constant back over to the other side. So that'd be adding 1 to both sides. Divide by the coefficient. And looks like x is going to equal 3 in this problem. Okay, number 6. Again, distributed property to take care of here first. So multiply the 7 into the parentheses. It's going to give me negative 7 minus 14p. Now I have variables on both sides, but I have only variable terms on the left side. So I'm going to move the ones that are on the right side over there with it. In this case, that'd be adding the 14p to both sides. Just so happens that it does also give you a positive coefficient here. So I get 7p is equal to negative 7. This time it only left me with a one-step equation since I only had variable terms on one side there. Sorry, I had just a variable term on the left side. So by moving the other variable over there with it, still just one term there. So all I need to do here is just divide by the 7, and p will equal negative 1. Okay, column question over there, why don't we move the variables to one side first in examples 5 and 6? So think about that and see if you can come up with an answer. I'll write my answer in on the completed copy of the notes. Same thing for the conclusions here. So conclusions, if you want to go through and work those out on your own, that's good practice, or to kind of walk yourself through what that is. I'll have it filled out on my completed copy. But let's do the summary here real quick together. So describe with words what is happening in each step that is following for solving the following equation. So we went from 3 times the quantity x plus 1 minus 5 is equal to 5x minus 2 to 3x plus 3. So they got there because they did distributive property. So okay, and then after distributive property, they combined the remaining like terms here. So we had a positive 3 and a negative 5, both just constants. So combine like terms. In step 2, then they subtracted 3x from both sides, and the reason they did that was to move the variables all to one side. Okay, and then added 2x to both sides and divided by 2, and here they got an answer of 0 because they were left with 0 after they added the constant, but that's called solving a two-step equation. So solved two-step equation. Okay, and that's typically the steps that we follow when we have variables on both sides. So take care of any simplifying you have first, and then move the variables all to one side using that inverse operation of either addition or subtraction, and then solving the resulting equation, which is typically a two-step, sometimes just a one-step equation as we saw though. Okay, so find the worksheet on this, complete that, and be ready for the quiz.